What's up guys, my name is Rohan and I'm an instructor with Chegg Tutors. Today I'm introducing the law of conservation of mass. Let's begin by breaking this term apart a little bit. By mass, I just mean the amount of stuff in something, or more technically, the amount of matter in an object or a system. And by conservation, I just mean that the amount of stuff stays the same. The mass doesn't change. Pretty simple, right? Okay, so let's look at an example. In this diagram, I drew an ice cube melting into a puddle of water. In the solid state, the water molecules are held together by a repeating pattern of hydrogen bonds. But as the ice starts to melt, the molecules start moving around a lot faster, the bonds start to break, and the ice loses its solid structure and turns into a liquid. Some of the liquid might even start to evaporate and become water vapor, even though I haven't drawn that here. Now, if you could take all of the water from the air, from the puddle, and from the remaining ice, and pull it all together and weigh it, you would find that it has the same mass as the ice cube did before it started to melt. And this is a perfect demonstration of the law of conservation of mass. Okay, so in that last example, we saw a physical change in the state of matter, meaning that even though the water molecules were still water molecules, they were changing with respect to their physical arrangement. In this case, we're going to look at something a lot more complex, which is a chemical change or a chemical reaction, meaning that the atoms will actually reshuffle from certain molecules into certain other molecules. As we can see from this, the carbon moves from the carbon dioxide on the reactant side to C6H12O6, which is glucose, on the product side. So does this mean that we're actually having a change in mass? Because, we're definitely having a change in the number of molecules, right? We have 6 plus 6 molecules here, which is 12, and we only have 7 here. But does this mean that we're actually having a change in mass, the amount of stuff? Well, let's find out. Let's add up the number of atoms on both the reactant and the product sides. So if we look at the reactant side, we see that we have how many molecules of carbon? Well, we have 6 because we have 6 molecules of CO2, which means 6 atoms of carbon. How many atoms of oxygen do we have? Well, we have 6 times 2 from the carbon dioxide plus 6 from the water, so we have a total of 18. How many hydrogens? Well, we have 6 times 2, which is 12. Now we can do the same thing for the product side, and we'll find that we have the exact same number of atoms, which in turn means that we have the same mass on either side. So again, this is a perfect demonstration of the principle of conservation of mass. Okay, last but not least, I want to review some important terms. The first is closed system. A closed system is one that doesn't exchange matter or energy with the external environment. The law of conservation of energy only works with closed systems, so remember that. The second is physical change, which we touched on briefly when we were talking about the ice cube melting. Like the ice cube, a physical change involves the rearrangement of molecules without a rearrangement of the atoms that make up those molecules. So the water molecules stayed water molecules, they just rearranged themselves physically with respect to each other. A chemical change, on the other hand, does involve a rearrangement of atoms, which we saw with photosynthesis when the carbon, hydrogen, and oxygen atoms moved all over the place and were transferred from one molecule to another. Alright, that's it for today, guys. I just hope that the next time you see an ice cube, a plant cell, or the next time you think of the universe, your mind immediately goes to the law of conservation of mass. That's all for this video. I hope you enjoyed it. Make sure you come find me on Chegg Tutors. Again, my name is Rohan, and I'll see you in the next one. Drawing dots, drawing lots and lots of dots. The dot song, everybody.